What's up, everybody? This is Coach Sharp. Welcome back to my Algebra 2 notes videos. And today we're going to do the second half of our graphing quadratics characteristics notes. It's just a couple slides of notes, and then we're going to look at Desmos with some examples of these. So let's get started. Let's actually share the screen. So just clicking on it so y'all can see it. That will help. All right, so we're picking back up from our notes from the last video where we started talking about all the characteristics of graphs of quadratic functions. You got the ones we previously talked about that you can get by looking at the graph. We also had these, which we'll look at now real quick before we go into more detail. I told y'all we look at these in the next video. So characteristics we get by looking at vertex form. It's plus or minus a, parentheses x plus, or you can only do plus or minus c here, squared plus or minus d. You can get horizontal shift and vertical shift, which are like our translations from geometry. Reflection, which is like a reflection in geometry, and then stretch or shrink, which is like a dilation. We did a dilation in geometry. So like we did on the last video, y'all can write these down. Y'all can pause the video to write this down. We're going to go into more detail in the next couple slides. Again, pause the video to write this down. I'm going to go ahead and jump to the next couple slides though. All right. So again, characteristics by looking at the function in vertex form, have the vertex form written again. We start with horizontal shift. I'll keep it like this. Horizontal shift shown by the letter C goes in the opposite direction of the sign. So this is where we got to think about if we got a coordinate plane. If I got the y-axis right here, if we're going horizontal, so if we're going left and right, here's my y-axis. Left is negative is usually going to the left. But in reality, we have to shift 3 to the right because that minus 3 that's in there is taking away from whatever we have. And we want the positive 3 to cancel out the negative 3 in essence to get us back to whatever our original x squared would be. It's a little confusing to remember. So you don't have to remember the reason why, but just know when we do the horizontal shift, we go in the opposite direction of the sign. So x minus 3 squared is not a shift 3 units to the left. It's a shift 3 units to the right. Then x plus 2 squared is not 2 units to the right, but it's 2 units to the left. The vertical shift is shown by the letter D. I'll put these in quotation marks because I think I have A in quotation marks later on. It goes in the same direction of the sign. So this plus 3 is going to be after x whatever squared. Plus 3 is shifting 3 units up. Again, if we're thinking positive, if we think it up and down, positive would be up, negative would be down. So plus 3 shift 3 units up, minus 5 is shift 5 units down. Pause that if you need a minute to finish copying it. I'm jumping to the next slide, trying to keep this video relatively short, even though you do need to pause and copy. All right, reflection, represented by a negative sign somewhere in front of x squared. The placement will determine if the graph, so I should say the graph here. Let me actually do that. If the graph reflects over the x-axis, the y-axis, or reflects at the vertex. Stretch and shrink is shown by A. So got A up there shown by A. It's like a dilation like we did in geometry. It's represented by a coefficient somewhere in front of x squared, that A. If it's greater than 1, it's a stretch. If it's less than 1, it's a shrink. Again, with that one, kind of depending on the placement of your number, you're still going to have the stretch or shrink, but it might move the graph around a little bit too, which we'll look at in a second. So then y'all pause that to get it down. Once you do that, you can continue the video. And I'm going to jump to Desmos. All right, stop that share. Let's jump to, let me actually switch to Desmos. clear out Desmos. And we'll get started. All right. So here's Desmos. Again, desmos.com/calculator. I'm going to start by typing in x squared, which is our parent function. Again, I'm just typing it on my keyboard. Here's the Desmos keyboard if you want to use that. It's this out of the way so y'all can see it. You can use this or your regular keyboard if you're actually on your Chromebook. And if you're doing this on your phone, either on the web browser on your phone or in the app on your phone, you need to use the Desmos keypad. So I'm going to start with typing in x squared. All right. Here's my regular parabola. So we're going to look at the different transformations just to see how it kind of moves. All right. So we're going to start with x minus 3 squared. We could see from our green graph to our purple graph, it has shifted over, and it has shifted over 3 units. You can really look at, let me annotate. You can really look at any point. So this point is actually -2, 4. The ordered pair, it actually slid over here to +1, +4. So it moved 3 units to the right. All of our points on the parabola are moving 3 units to the right. But we focus on the vertex because the vertex is really the easiest thing to see. So our vertex originally started at the origin. Again, x squared is our parent function. I think I failed to mention that. X squared is our parent function. All right. You got 0, 0. You'd have 1, 1 right here if I click on it. -1, 1. 2, 4. -2, 4. Oh, it's not gonna be 10. That's kind of cool. I can't move it around. Guess I need to delete it so it'll go away. 2, 4 would be -2, 4 would be right there. Got -3, 9, if it'll settle. +3, 9. So the green is my parent function. And the purple graph is, so my parent function, the vertex, got a little bit ahead, guys. Sorry, my thoughts are coming back and forth. My vertex is at 0, 0. And then for my purple graph, it's at 3, 0. So we see it move 3 units to the right. Again, since they kind of cross it, I think you can still see it relatively easily, but the graphs are still the same exact shape. Okay. One hasn't gotten bigger or smaller or anything like that. Let's change this now. Let's do +8. Let's do +12 and go further. There we go. +12. So now it's shifted 12 units to the left, gone. If we look at the vertex, gone from 0, 0 to -12, 0. And hopefully you can clearly more see it now. This same parabola, I just moved it 12 units over. This one isn't any wider or skinnier than that one. It hasn't reflected or anything. All right. You can also have both. It's not just a one or the other situation. You can have both. So I'm going to do -3 and then I'm going to do +2. So vertex moves from 0, 0 to -3 goes the opposite way. So 3 to the right. +2 goes the same way. So it goes up 2. So there's my vertex. Nice. Now I'm going to get rid of this one so we can look at the reflections. So I said in the reflections, it kind of depends on where the negative sign is. All right. So this is what I'm going to do. I'm going to add in an extra set of parentheses to demonstrate. All right. So my negative can be, it's got to be in front of X, but it cannot be in 3 places. Literally in front of the X. Out here in front of this first set of parentheses. So when it's in front of this first set of parentheses, if it's just on the X, whatever X originally is we're changing the sign. If it's right here, I can make the negative sign. If it's right here in front of this first set of parentheses, we would do our math here. So we would do, if X was 5, we would do 5 minus 3 squared, which is 2. So I would get 2 squared, which is 4. And then I would make 4 the opposite sign. So it would be negative 4. And then you could add the 2 onto the back if I was trying to, well, again, I'm plugged in 5. So I was trying to see, 5, what would be my ordered pair. So if I stuck my negative sign there, that's what would happen. Again, if I originally did it, if I originally had it in here, if I originally had it on the inside, it would just be negative 5 minus 3 squared, which is negative 8 squared, which is 64. And then still the plus 2 on the end. Lastly, if I stuck it all the way on the outside, what that means is I would do 5 minus 3 squared plus 2. 5 minus 3 is 2. 2 squared is 4. So I got negative 4 plus 2, which is 6. So opposite of 6, which is negative 6. So, where I put my negative sign is going to I'm going to get different numbers, but this is how it looks when I actually do a reflection. All right. So I'm going to start with just sticking the sign on X, the negative sign just on X. It's reflecting over the Y axis. Okay. I think everybody can see that. It's reflecting over the Y axis. My vertex is moving from 3, 2 to negative 3, 2. And coincidentally enough, my y-intercept is still staying the same at 0, 11. Okay, again, it's not coincidence. It does that because of how the math works out. But all right, so now I'll stick negative here. So I'm gonna do my x minus 3 squared, then make it negative, then add the 2 to it. That's what this negative sign is saying. So now if I do this, my graph is flipping upside down. It's reflecting to face down, but it's not reflecting over the x-axis. It's flipping at the vertex. My vertex is staying the same, 3, 2, but it's flipping at the vertex. Okay. And then the third one is if I stick the negative sign out here, now this is actually going to flip over the vertex. Okay. So depending on where we stick the negative sign is going to depend on the kind of reflection we have. I don't think I'm going to ask you to get too specific in terms of if it reflects over the x-axis, the y-axis, or reflects at the vertex. Any reflection, and again, you won't necessarily be able to tell if it reflected. Well, you can kind of tell because if it reflects at the vertex, you're still going to have some part above the x-axis, and then it's going to cross over and go below the x-axis. And if it was out here where it actually reflected over the x-axis, the entire thing would flip down below and it wouldn't cross it. So you can kind of tell, but I'm not going to ask for that specific. I'm just going to ask, if it's pointing up or if it reflects and flips downward. Okay. The last thing is my coefficient out in front. That was about ring in 5 minutes, 36 seconds. So I need to try to wrap this up. I'm going to bring back our original equation. Now I'm going to type in 5x squared to put my exponent out here, or my A out there, my coefficient. So we can see 5x squared, my purple graph actually gets skinnier from my blue one. And I'm gonna try to show it the pipe cleaner because I don't have anybody to assist me with my headphones like I did in class, plus I'm wearing them. But if I have the ends of my parabola and I pull them up, my parabola is going to get skinnier, right? If I pull my ends up, it gets skinnier. So I stretched it out and it got skinnier. It's the opposite of what you would think. When it gets skinnier, you think, again, your mind wants to say that's a shrink because you see it getting smaller, but it's actually, again, it's getting skinnier because I'm pulling the ends up. I'm stretching it out. Again, my example is, you got the kid that was shorter in 8th grade and, maybe kind of looked normal in 8th grade, or maybe was, again, look, I don't know how to say something video, but, hit like a 6-inch growth spurt in 9th grade and shot up and really grew into his body. And, if he was already kind of skinny, he got super skinny. Because he got pulled upward, right? So now 1/5, now I do it the other way. Now it gets wider because, again, now when I push down, when I'm pushing down, it's going to flatten out and get wider. Okay. It's going to flatten out and get wider. So, with my stretch and shrink, I can make those negative as well. It'll flip upside down. Negative 5x squared. Again, it got skinnier and flipped upside down. You can stick other things with this as well. Negative x minus 2 squared plus 3. So my vertex moves to 2, 3. With the negative out here, it's actually kind of funny because the negative 5 out here, if I stick the negative 5 in here, watch what happens to my vertex. Okay. If I stick the negative 5 in there, again, it started over here, so it reflected over the x-axis, didn't flip upside down. And then when I made the 5, not only did it get skinnier, but my vertex, you see my vertex actually moved. It moved from here, it got closer to the line. Okay. Again, there's all kinds of things you do. I can leave my 5 like that to where it stays super skinny, stick the negative there, and then it'll flip. I can make this negative and put the 5 out there. So there's a lot of kind of combinations that I can do. A lot of combinations like that. I sure as I was blocking my hand with my mouth in my hand. All right, so there's the different examples of our transformations. Again, I'm gonna do a third video where I actually do examples. The first one's going to be the one I did in class Tuesday, x squared plus 6x plus 8. All you have to do is find domain and range, all that stuff. For that one, the next one I do will be the one that's on the note sheet in class, the one that we did in class. X minus 2 squared minus 8, number 3 there on the in-class practice. I will do that one on the video as well. Again, I don't, I want to give you all examples, but I don't want the video to go forever. So I'll kind of see how that goes. Maybe I'll try to do a couple more quick ones on that video. But I do have a third video with the actual examples of what we will be doing coming. All right, so there's that. Again, be on the lookout for that examples video. Until that video or until I see you on class, see y'all.